In this video I'll step through the process of attaching the DragonLink long-range 433 MHz control system to my trusty Spektrum DX7. As of early 2012, the components you receive with the DragonLink transmitter receiver kit are the transmitter module. It's a 500 milliwatt 433 MHz transmitter. It's got a dummy test load which just appears to be a little cap, but actually contains, I believe, a resistor or some sort of small circuitry inside this cap that mimics an antenna, so that for testing purposes you put this cap on. It does not damage the circuitry internally, but it does permit a very tiny fraction of the transmitted signal to escape for range testing. It's very important that either an antenna or this test cap be in place. There is a 16-inch whip antenna, which appears to be in very good quality. It's rigid enough to stick out or up straight, but has just enough flex in it to be safe around yourself and environments. And I put a 90-degree SMA connector on there because I typically like to wear my transmitter horizontally, and it's usually best to have the transmitter antenna element vertically oriented, or at least parallel to your aircraft, and the antenna on the aircraft is usually going to be vertical. So I've chosen to put a 90-degree connector there. Together, the transmitter module and the antenna weigh 5.7 ounces or 162 grams. On the receiver end, we have the receiver module itself, which is about 1.5 times the overall volume of an average full range Spektrum receiver, I would estimate. It is 12 channels and has an RSSI, that's received signal strength indicator, out right here, which is highly convenient and valuable. It has the SMA antenna jack here, parallel to the long axis, so I may or may not need a 90-degree adapter to that. It is about 3 inches long, 1 inch wide, and appears to be 2 printed circuit boards attached back to back with some hot glue in between, wrapped in shrink wrap, which is clear, and it's a pretty solid feel to it. Also comes with an 8-inch whip antenna of similar feel and quality to the transmitter antenna. It's well built and sturdy, but flexible enough to avoid damage in flight and handling. It also comes with this dipole antenna with a length of antenna feed line of your specification from 12 up to, I think, 36 inches. And one of these is soldered to the feed wire center element and the other to the ground. This is just hot glue. It appears to be well done. It would have been nicer if it was encased, but I'm sure it's going to work just fine. And presumably the leads are tuned to the 433 MHz frequency. This SMA connector clearly also inserts right there and screws on nice and tight, so that the antenna element can be located remotely from the receiver if that's what you choose to do. The receiver and whip antenna weigh 1.8 ounces or 52 grams, and the receiver and the dipole antenna weigh 1.4 ounces or 39 grams. Now, unfortunately, Spektrum DX7 doesn't come with a removable radio module here that you could more easily attach the DragonLink pins to. So I'm going to have to hack into the back of this and put in a connector that will permit me to use this Spektrum with 2.4 gigahertz when I want to at the park, but then to easily plug in my DragonLink for true long-range performance out at the FPV site. Now, while the Spektrum DX7 does have a trainer port right here that sends the control signals from this transmitter to another transmitter, it is universally recommended against using this trainer port to get a strong, reliable control signal out of to operate secondary transmitters like the DragonLink. The DragonLink website and any other resource you can reference recommends against using this trainer port, so I'm going to have to tap into the main signal. Now, different transmitters of different brands with and without the removable radio module here have different configurations of circuitry, but they do have one commonality for the most part, and that is that these signals will come through a light colored wire. This one is yellow. They'll need a power supply, usually represented in red, and a ground for both the power and the signal circuits, and that is usually represented in brown or black or some dark color. So now, ready to disassemble the back of my DX7, I'd like to take out the battery pack before disassembly to avoid shorting out anything inside or accidentally turning the unit on with the antenna disconnected, which could damage the internal components. There are 6 screws here, which I like to reach with a screwdriver with a little magnet stuck on the side so that I can extract the screws out using the magnet. I've already removed those 6 screws. Keep those safe. And these 2 halves are attached by a wire, so don't just whip them apart. They come apart. And the power lead there, you'll see in orange and gray. Be sure to keep these 2 halves close enough to one another that that wire isn't stretched. Here's the inside of the Spektrum DX7. This elevated printed circuit board you see here is the transmitter module circuitry. That is analogous to this in the DragonLink. All the components you see here in 2.4 gigahertz are inside here at 433 megahertz. The signal generated by the remainder of the DX7 through the sticks, switches, and the rest of the computer circuitry here is delivered to that module through these leads here. The yellow is the actual signal of your controls that are transmitted to the plane. The red is the power to this module, and the black is the ground. These are analogous in the DragonLink to the orange for the signal, red for the power, and brown to the black for ground. What we're going to do is insert a switched socket in this circuit so that the signal can still be sent to the 2.4 gigahertz transmitter for park use of this radio, but can also be switched to the DragonLink for long range use. What I'll be using to permit switching back and forth between 2.4 gigahertz and 433 megahertz with the long range is this 3.5 millimeter switching jack. I've gotten a surface mounted version where the pins come out the side, which offers a lot of space in between the pins, so it's easier to solder to them, and there are 5 pins. The important part about the switching jack is that in its native resting state, as you see it here, the signal is bypassed into this module and then back out for use when you're working in 2.4 gigahertz. But when you plug in the plug from the DragonLink, it actually, and you can see the little parts move apart, it starts to transfer the signal and the power to the plug that goes to the DragonLink. I like 3.5 millimeter plugs because they're fairly universally available. You can actually take one off of a stereo headphone set like an iPod earbuds if you like, or easily buy these extensions and cut them, or you can actually buy these little plugs separately and then do the soldering inside here. I usually find it's easier to actually solder wire to wire, but that's up to you. Okay, so now I've got my switching 3.5 millimeter jack placed here. I first placed it with some 2-sided tape and then closed up the radio to ensure that it didn't hit on anything on the inside. Then I used a small drill bit and then a Dremel tip to carve out the plastic a little bit so that it fits in there nicely, and as importantly that enough of it protrudes from the plastic that you can install the little collet that holds it out flush with the radio, and then finally fit it closed like that to ensure that everything closes up tightly without forcing. There is the jack. It's nice and out of the way, and it will accept the 3.5 millimeter plug and plug in all the way. And so this will be the lead that now goes to the DragonLink module. Here's a quick look at the 3.5 millimeter switching jack that I have. Different manufacturers will place these soldering pins in different places. Sometimes they're on the end sometimes they're on the flat surface here. But so what really is going on, so you can understand, is there are 3 contacts which correspond to the 3 contacts, metal contacts on the plug itself, which are commonly referred to as the base, the ring, and the tip. So in the corresponding contacts in the jack, this single one is the ground, and it must be the ground. There is no switching that goes on with this single contact, and that corresponds to the base of the plug. So that's the part that's nearest the plug itself, right here at the base. The other pins on the jack occur in pairs. You'll see there are 2 here, which I've marked with a yellow because I'm going to use that for my signal wire. And then these 2 I've marked with red as I'm going to use those for the power wire. And so in the unswitched state, that is when using this with the 2.4 gigahertz radio in its normal state at the park, the signal will come into this pin, and the circuit is closed normally, so it will flow out of the other pin, and so that pin will go back into the transmitter module of the radio itself, 2.4 gigahertz, and then the power, 12 point whatever volts you're using, goes in this pin and right back out the other pin and powers the radio transmitter module at 2.4 gigahertz. Now where things change are when you go to plug in the 3.5 millimeter plug, as it pushes these contacts inside apart so that the signal goes into the plug and the power goes into the plug and bypasses the 2.4 gigahertz module. Here's the nervous part where I need to cut the signal, power, and ground wires in my Spektrum radio with enough leads left going into the 2.4 gigahertz module here to solder, and then bypass the yellow. I'll be using a JR style servo extension that I've just cut into 2 10-inch sections, which will easily go from here over to the jack here, and then of course back to the 2.4 gigahertz module here. So now the power, ground, and signal wires on their way from the radio itself to the transmitter module have been split, with yellow to orange, red to red, black to brown if you're using JR style extensions, and these 10-inch extensions will make their way over to the 3.5 millimeter jack here. I'm going to take care to route these wires beneath the transmitter module and away from the stick gimbal and any other sensitive moving parts. So I'm going to actually wrap it up under here and bring it out here. Just use your discretion on that. Now I've got the jack soldered up with the supply, power, ground, and signal from the radio itself going to the proper junctions in the jack, and the line to the 2.4 gigahertz module here soldered accordingly. I recommend checking these with the circuit tester as you go to ensure that in the normally closed position that the 2.4 gigahertz still receives signal from the orange, power from the red, and that when the plug is inserted that the signal and power supply are properly routed to the plug itself. And finally we'll install the jack here that you see the soldered, where this one is I've just placed for demonstration in the side of the radio chassis, and then close it up, taking care not to contact anything with these pins or apply undue pressure against any of this assembly. I'm going to encase this in hot glue just to relieve some of the possibility of mechanical stress and electrical shorts. Now it is time to map the leads from the DragonLink transmitter module to the 3.5mm plug that's going to plug into your radio. And so remember, I've used power at the tip, signal on the ring, ground at the base. And you'll need a circuit tester or a continuity checker like this to map out which contact goes to which wire here on the lead here. so that you'll know which of these to connect to which of the leads to the DragonLink. Don't trust the colors. These can be different between manufacturers where you got this plug. So for this particular connector, it will be white to yellow for the signal, red to red for power, and copper to brown for ground. I have to emphasize these connectors will be different between manufacturers in different situations, so be sure to map out the plug to the wires before connecting to the DragonLink. Now that the 3.5mm plug is correctly soldered and heat shrunk onto the DragonLink, it's time to mount the DragonLink on your transmitter. Now a lot of guys like to put this on the back with the antenna sort of protruding up past the top in the vertical position. I'm going to mount mine on the front just for ease of accessibility, and also I like to be able to set my transmitter down on a flat surface without resting on the DragonLink. So this is now attached. So now it's time to plug this in. It's imperative that the entire unit be powered off during this plugging operation because the signal and power contacts inside the jack actually cross each other as you plug it in. If you've ever noticed when you plug in headphones, you get that buzzing noise because the power momentarily goes through the signal wire. We don't want that in this case in this delicate electronic, so make sure that it's powered off. And then that can be just plugged in. And then the final step, ensuring that either the antenna or the dummy test load is affixed to the antenna SMA plug. And then we can turn this on. And notice we've got power right there. Happy green LED, so it's time to bind, range test, and fly this. So here is how it appears in its final finished version. Put the antenna on, sits down flat, hangs from the neck angled slightly away, which is how I like it, but personal preference dictates.